I am Santosh Gadankar. Today I am teaching you a constant volume process, also called as a isochloric process. Constant volume process is also known as a isochloric process. Isochloric process. Here, here in a constant volume process, the the working substance gas working substance is a gas is heated or cooled inside closed rigid vessel. Hence, the boundaries of the system are not movable, and no work can be done on or by the system. This process is also known as isochloric process. Isochloric process. This is rigid vessel. Hence, the boundaries of the systems are not movable, and it is and not work can be done on or by the system. This process is also known as isochloric process. Now, I will consider a figure. Inside the figure, gas is there, and these are insulated. Bottom burner, and heating is done. V is equal to C here. This is vessel, and the burning occurs. If you go for a PV diagram, pressure and volume diagram, here a straight line will appear. Here the boundaries are volume is constant, the pressure increase and decrease occur, state 1 and 2. It moves up means heating occurs. If it moves downward, it indicates the cooling occurs. Here P1, P2, and volume V1 is equal to V2. 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 Now further, in order to derive, first we are going for first A, the relationship between P, V and T. We are going to have a proper relationship between P, V and T. P, V and T. Now by using the general gas equation, we need to arrive a relation here. Now P1 V1 divided by T1 is equal to P2 V2 divided by T2. This is a constant volume process. Here V1 is equal to V2. Therefore this and this get cancelled. Hence further it becomes P1 divided by T1 is equal to P2 divided by T2. Further P1 divided by P2 is equal to T1 divided by T2. This is the relation between the pressure, volume and temperature. Next B, work done during the process. We are going to find out the work done during the process. We know that delta W or W is equal to P into dV or integration of 1 to 2 P into dV. Integration of P1 into integration P into dV. Further, W can be written as P as a constant 1 to 2 1 dV. We know that integration of 1 dx is nothing but x. Here integration of 1 into dV becomes V. W is equal to P V 1 to 2. W is equal to P V2 minus V1. As we know that V1 is equal to V2, therefore this becomes 0. Therefore work done will be 0 or delta W will be 0 in the case of constant volume process. Now see change in internal energy. We are discussing about the change in internal energy. Delta U is equal to du or U2 minus U1 is equal to integration of 1 to 2 mCV dt. This is the formula for internal energy. Here further mCV outside integration 1 to 2 1 into dt. Further, it is similar to integration of 1 dx is nothing but x. Here m cv integration of 1, because they are related to dt, you have to go write t here. 1 to 2 m cv t2 minus t1. That means delta u du u2 minus u1 is equal to m cv t2 minus t1. This is the important formula in change in internal energy. Next is about heat transfer d, heat transfer transferred. We are discussing about the heat transfer here. Heat transfer as per the first law of thermodynamics. As per the first law of thermodynamics, delta Q is equal to delta W plus delta U, or you can also write as delta Q is equal to delta U plus delta W, 1 and same. Here the constant volume delta W will be 0. Therefore delta Q is equal to delta U. That means delta Q is equal to, you can write this formula, delta U m Cv T2 minus T1. T2 minus T1. E, last one, change in entropy, change in enthalpy. You are finding change in enthalpy here. As we know that formula for enthalpy is H is equal to U plus PV. For the state 1, H is equal to U1 plus P1 V1. For state 2, H2 is equal to U2 plus P2 V2. And we know that dH is nothing but H2 minus H1. Substitute the values here. dH is equal to U2 plus P2 V2 U1 plus P1 V1. Close the bracket. Further, it can be written as U2 plus P2 V2 minus U1 minus P1 V1. Rearrange it. U2 minus U1 plus P2 V2 minus P1 V1. We know that PV is nothing but MRT. PV is nothing but MRT. And U2 minus U1 is nothing but MCV T2 minus T1. Substitute here. MCV T2 minus T1 plus, here I am going to write, take R as a common, MR as a common, taking MR as a PV, I would write T2 and T1. That means P2 V2 is nothing but MR T2, P1 V1 is nothing but MR T1. mRT1. We know that R is equal to Cp minus Cv. Substitute in place of R. We need to substitute here. We need to substitute here in place of R. Now substitute mCv T2 minus T1 plus mCp minus Cv T2 minus T1 minus T1. Now multiply mCv T2 minus mCv T1 plus now mCp T2 minus mCp T1. Next minus mCv T2 minus, it becomes plus, minus and minus become mCv T1. mCv T1, this and that get cancelled. mCv T1, this and this get cancelled. These two things are remain. mCp T2 minus mCp T1. Take mCp common, T2 minus T1. This is the formula for enthalpy, change in enthalpy. I am Santosh Gadankar. Thank you very much.